music will wake you up at 9 o'clock
absolutely.
in the morning. Heather, you've been doing this for 15 years at Google. You've been keeping their servers and their IT networks safe. But that's not where you started out. Your career has a few twists and turns.
Yeah, so I like to tell people that I grew up in a small desert where there really wasn't a lot to do other than to read and to learn about computers. And that's where I fell in love with technology. When you have nothing else to do in your life, that's a really good way to go. And then when I went to school, I decided I wanted to go somewhere where it rained and had life, vibrant life. So I went up and I studied marine biology on the north coast of California. And it was there actually that I realized how much we were using computing in the sciences. And not just little computers, which I was used to, but huge mainframes and VAX systems, Unix systems. And I fell in love right then and there and sort of stumbled my way into being a sysadmin and IT. And it was while there at my first IT job that I got hacked. And the rest is history.
How did that happen? How does the Google's head of IT security get hacked?
So it was a small business, and this was a time actually long before we talked about vulnerabilities as an industry. And for those of the audience who might remember, vulnerabilities were announced on a little list called Bug Track, and you just sort of had to pay attention to this list. And vendors were somewhat inconsistent about patching them. And so you could just go online or your favorite BBS and find a Unix exploit and sort of hack into just about anything at the time. Yeah.
That has changed a little bit since then.
It's changed a little bit since then, yeah.
Now, the last time Google, Jordan just introduced it, the last time Google really got hacked was in 2009. Mm-hmm. For those who don't quite remember what happened back then, what's the story?
So in December of 2009, we discovered a sophisticated attack against our corporate infrastructure that resulted in the loss of intellectual property. And in the course of our investigation, we discovered this was actually affecting at least 20 other companies as well. And we believe, based on what we saw, that this was primarily targeted at long-term access to Gmail accounts, which for us was a wake-up call. We had always been very serious about security. In fact, I can't remember a time when our leaders were not talking about it. But we learned so much about how much security had changed since we had all entered into the industry. Mm-hmm. And this set us on quite, I think, a radical and interesting path.
Yeah, you've definitely changed the way you think about security at Google since then. You had the Beyond Core project, right? Mm-hmm. Maybe you can talk a little bit about that, because I think that's such a radical change from how everybody else is still thinking about security today.
Yeah. So if you think about the way we set up companies in the 1980s, 90s, and even into the 2000s, the idea is that you go out and you buy off-the-shelf software and you create an enterprise network. And this kind of becomes your castle, right? And you want your employees to work inside the castle. But the reality is that employees want to work outside the castle. They roam because you have customers in the field, or they roam because they want to work at home. And the very nature of work is changing in such a way that this enterprise castle no longer works. You can't just put a firewall around your network or even physical walls anymore. And this was really striking to us in terms of what we saw in 2009. And so we initiated this project, now called Beyond Corp, to sort of tear the castle down and to realize that the castle walls actually belong on the device rather than on the network. So if you have a phone, if you have a tablet, if you have a laptop, that should really be the thing we look at and verify that it's secure, verify that it's patched, that it has the kind of security software on it that we want to have, and that you are the human who is actually using it. And so when we can actually verify this device, then we make the decision that it's okay to access email, to access cloud-based documents, etc.
Without a VPN?
Without a VPN.
That sounds suicidal.
Suicidal. Well, remember, the purpose of VPNs originally were to create private networks, right? To put confidentiality on the connection between the endpoint and the server. And we can achieve this today with SSL. So the Beyond Corp model, especially in a world where so much of the internet exists as a web-based application, we use SSL to protect that and to provide that confidentiality capability.
Now, Google has the resources to do something like this. Most startups don't. They actually do use firewalls, right? Would you recommend them to move away from that?
So I think this is the future of the enterprise. You're already seeing this with the plethora of cloud-based applications. For example, today, if you are a Salesforce user, a Google Apps user, and maybe you get your HR from a company like Workday, you're already working in the cloud. And when your employees roam, the creation of a VPN into a corporate network is, I think, somewhat anachronistic, right? Because you're sort of sending your traffic through the VPN to a corporate network and then into the cloud. Why not just straight to the cloud? And I think this is actually the future. The technology to make this happen is actually available today. We have it in Google Apps via a gateway proxy, and you're seeing other companies adopt it as well. Even Microsoft has solutions that allow you to interact with their infrastructure sort of in the cloud. Right? So it's coming, it's here, and it's the future.
And you haven't had a hack since? Nobody has gotten into your systems since you've made that move?
We have malware just like everyone else. What we have found is that the end user, in the endeavor to do their work, introduces all kinds of interesting chaos into the network. And really the job that we set out to do and that I think we've achieved is to make sure when those things happen, they're dealt with almost immediately, right? And so we wouldn't consider them to be an intrusion. They're just sort of, little noise in the network.
Steady trickle of
things, yeah.
Now, your colleagues over at Yahoo had these really big breaches over the years with a billion accounts affected. Took them years to find out that actually happened. Could something similar happen to your network and to Google?
It could happen to anybody. And in fact, we are seeing it happen everywhere. And I think the thing I ask is, are we ready? Are we ready for that to happen? I think we have lots of startups in the audience. And if you take one thing away from this fireside chat, think about this. At some point in the history of your company, you are probably going to get hacked. If you look at the Fortune 500, all of them have had breaches. We have the very notable Equifax breach very recently. The question isn't whether or not you're going to get hacked. The question is, are you ready? And do you have a team in place? Have you put your procedures in place, written them down, practiced them? Are you going to be able to very quickly make decisions about what to do next? And the companies who are really good at security are good at that, right? We don't measure them about whether or not they get hacked. We measure them about how quickly can you deal with it after the fact. Yeah.
Are you ready?
I think we're ready.
What's that going to look like the day Google gets hacked and 1 million Gmail accounts are compromised?
So I don't think that's actually the scenario. I think that the walls internally are big enough to repel that. I think the biggest sort of vectors, and I don't exactly want to give a roadmap on how to hack Google, that would be very unwise. But I think that this week we saw something very interesting. If you've been paying attention, there's a project called PI, and we don't quite know who is responsible or what their intent was, but they went in and they created another project called the same thing with a number of libraries and put a little back door in them so that when you went to install these Python libraries, you would accidentally download the malicious one and it made a TCP connection out. We don't know the purpose. It could have just been research. But I think these little problems in the supply chain are actually the problems we have to think about.
Well, that's kind of the problem that Equifax had as well, because they had this unpatched library. But every project these days has dozens of these libraries.
Yep.
What would be your recommendation for keeping up with that? Because if I'm a developer, I can't keep up with that.
Yeah, I think you have to. I think this is the cost of doing business with open source software, which is a wonderful thing. It enables so many people all over the world to start new companies, to do research, to start new projects, and to really push the boundaries of technology. But the reality is that we have to stay on top of it. So if you're a startup, and this is the general advice I give startups, even if you're just 2 people in a garage, one of you must be in charge of security. Somebody in your company must be in charge, whether it's part-time as an IT person or the lead software developer. Somebody must be paying attention. There was a great tweet, and I wish I could quote exactly who it was, because it was such good advice, but rather than spending tons and tons of money on technology, put a little money towards talent. Get some interns, get some junior security engineers, and just have them do nothing but patch. Like that would be a much better investment than paying $1 million for a security.
Is that what
solution.
Google does? Hire interns to keep up the security systems?
Well, fortunately, we have lots of automation because the size of our attack surface is big enough that we've been able to invest pretty heavily in technology as well. But to the extent that you're thinking about what to do first in security, I would invest first in talent and second in technology.
Looking ahead, you were talking about technology.
Mm-hmm.
Google is pretty far ahead when it comes to AI
Yeah.
and machine learning. And do you see that as a way of not using interns necessarily, but using technology better to defend yourself? And are you using that internally as well?
So AI and machine learning is really great for lots of applications. We use it in search. We're starting to use it in many other places. We have AlphaGo. It's my favorite, probably the favorite thing we've ever done at Google is watching Go. And I think the problem that we've had in applying this to security, and you see this in the research for the last 20 or 30 years, actually machine learning and AI was first proposed to solve this problem in the early 90s. And one of the things that works really well for AI is when the machine gets the feedback that it's doing a good job, right? So when it's playing Go, it's calculating all the probabilities and what the next right move would be. But we just don't have a sense of what is good and bad from a security perspective, right? Despite all the hacks you hear about, it's actually not enough data for the machines to consume and then use to play the game. And so we find in all of our experiments that, yes, the machine is really good at picking out anomalous behavior, but it'll also pick out 99 events that are really good, and then a human has to go through and sort them, and that's quite tedious, and it doesn't scale. So this is a huge area for research, we think, in terms of how to push the bar. What we are finding, however, is that AI for attack platforms is a far easier problem. And there was very recently a company, I think they're called ZeroFox, created an AI Twitter chatbot that taught itself how to fish, and it got almost 100% at the end of the experiment. We saw a similar kind of experiment with DARPA's Cyber Grand Challenge, which was played at Black Hat DEF CON last year, where the cyber reasoning system had to find vulnerability in software and then figure out how to exploit it and then patch itself against that exploit. And it works, right? So attack platforms, it's working really well, not as well on the defense.
What does it mean for the future, though, if the attacks are getting smarter and smarter and you can't use the same techniques to defend yourself against them?
Well, I think the techniques actually haven't changed that much.
Okay.
If you look at the classes of vulnerabilities, almost everything that we have today was actually described in a paper in 1972 by a gentleman named James Anderson, who was working on contract for the US Air Force. And he posited that the way that we were trying to use machines designed for single-user systems would not work in a multi-user system because there were no protections, for example, in the CPU to protect registers from one another. Or in RAM, we didn't have, well, they didn't really have RAM at that time, but the idea that that the data stored in the machine wasn't actually protected from each other, and there was a very notable vulnerability in RAM highlighted in 2014, 2015 called row hammer, right, which is an actual physics problem where the electrons jump between rows in RAM and flip the bits. So we've known about all these classes of vulnerabilities for a really long time, and it's not that the attacks are becoming more sophisticated, I think. I think the types of exploitation are becoming more sophisticated because the defenses are being raised a little bit.
So the AI attackers are not going to take over?
Well, I hope not.
Sounds like there's a bit of an imbalance
It's
there.
going to be a little bit of a race. And I think the third leg of that is what we're doing platform mitigation-wise to make the systems more resilient to begin with. And this is something I talk a lot about in terms of how we got here as an industry. We didn't design the systems by default for the purpose in which we're using them. I see lots and lots of laptops in the audience. You are actually using a supercomputer by most conventional terms, and it probably does about 1,000 things you don't actually need it to for whatever you're doing. But that's a huge attack surface that can be exploited to take over your machine. So what we're seeing being really successful here is the redesign of these systems and the way we rethink about them. Google has Chrome OS, which is a very slimline operating system that only runs a browser. And so we can spend lots of time going really deep on the mitigations there to make that much harder to exploit. Whereas if you're using a supercomputer, I could exploit 1,000 things on your machine.
But as an employee, I get a lot more freedom with those. Your Google employees don't get that kind of freedom on their laptops.
They actually have a shocking amount of freedom. I think they would disagree with that. I think that, again, because so much of what we're doing internally is in the cloud, we're heavily invested in that. We really believe in that and the beyond Corp world, that actually all the freedom they need is more or less available in that window into the cloud.
Now, a lot of what we're hearing about these days, except for Equifax, and maybe even Equifax, is state-sponsored actors,
Yep.
really sophisticated attackers.
Yep.
Is that something you're seeing as well? Has that changed over the years?
So there have always been state-sponsored actors. I think the first one I've ever heard about was around 1986, 1988. Clifford Stoll wrote a book about this called The Cuckoo's Egg, and this was a KGB contractor who hacked into nuclear weapons agencies for the United States government. So it's been going on for a long time. If you think about it, most governments on the face of the planet are engaged in some kind of surveillance or warfare, and it's not unusual for us to think about them having a digital or cyber arm to that. What I do see increasing trend-wise is that the attack platforms are no longer something that they have to build themselves. Okay. They're able to buy it off the shelves. And that means that if you're a smaller government, maybe with not a lot of money or talent within your own region, you can just go buy consulting services and software off the shelf. And so we are seeing, I think, a rise in the number of attacks that are coming, but there's plenty of sophistication in those attack platforms as well. Right.
So you're not that worried about China, Russia using zero-day exploits against
I'm always
you?
worried. Yeah,
Right.
yeah. This is my normal state. Worry is my normal state.
Anxiety.
Yeah, I'm always worried. Yeah, but I think it's our new reality, right? So it's time to get over being worried and actually do something about it.
How do you think about somebody like the NSA, who probably tapped your fiber networks as well? Do you think of them as a state-sponsored actor, and do you worry about them?
Sure, I worry about them. And it's good to worry about them and to wonder what they would do, because if they can do something, then anybody in the world could do something too, right? So we think less about, at least I think less about specific actors, and I think about the larger bucket of techniques that they can use, that a hacker could use. A technique the NSA could use could easily be used by the Mexican drug cartel against our users, or by the Russian organized crime, right? And all of these actors have these tools available to them, right? So I think it's more useful for us to look at the attack surface and how it's vulnerable, and to address that vulnerability as a common cause.
Sure.
Yeah.
Now, not talking about state-sponsored actors, but just individuals.
Yeah.
What's your advice to just a regular user today? How do you keep safe on the internet at this point?
Well, that's a really complicated answer. But quickly, two-factor authentication. So this is either a token or code that you get. Google has a security key, which is a physical device that provides the same functionality in a more usable format. That's incredibly important for all your online accounts, especially your high-profile accounts, your email. If you think about it, you probably put all of your secrets in email. It has become almost an extension of the brain. And I recommend people just not put some stuff in email. Like I delete all the love letters from my husband because I never want anyone to see them. So two-factor authentication, I think looking at the platform you use, if you're going to do really sensitive stuff online, find a platform like Chrome OS that is a little more difficult to attack. And I think also, I would say, despite the fact that it's not doing a 100% job, unfortunately, antivirus is still the best solution for most consumers. And so I do continue to recommend that, although it hurts me a little inside to do so.
All right, you got a plug in there for Chrome OS too.
Yeah.
Well done. Well done. Thank you very much.
Thank you.
Appreciate it.